Hello everyone, and welcome to this EDA Technologies webinar. I hope everyone is doing well and staying safe during these trying times. We're busy practicing safe COVID-19 regulations in our office as well. And yeah, so let's get this webinar started. For all new guests here and those who don't know me, my name is Dingle, and I'm the Altium Product Specialist for Altium South Africa with EDA Technologies, and I'm going to be your host for today. I would like to thank Altium for their ongoing support and assisting us with our daily activities. This morning, we've managed to steal a few valuable minutes from a very busy individual. He's the Global Director and our Territories Manager. It's Mr. Peliciari. Thank you for your time and joining us on the webinar. Pelle, would you maybe like to share a little bit of insight with us, your dealings with EDA Technologies and such?
Certainly. Well, welcome everybody virtually. So I'm, as Ellie mentioned, I'm Pelle Chiari, sort of run our strategic growth markets globally. I'm actually based out of London in my virtual office, as you can see behind me. So it's really great being with you. The first thing I always want to stress is, across the world right now, we're all going through really challenging times, aren't we? With the whole, new to all of us, around the whole pandemic situation. So the first thing is always staying safe and staying well. So that's the first thing I would really encourage us all to continue to do. So really, from our perspective, we've been working with EDA for several years now. And really, what's key really for us this year is really evangelizing really our whole focus around the EDA marketplace and supporting customers like you. So I know there's some really amazing stuff that the team here are going to be sharing with you around Altium Designer 20. We've got the whole, new collaboration tool that we made available to all subscription customers in Altium 365 that really allows customers to collaborate virtually, which is so critical right now as we all are either sort of working from our home office or working remotely right now, which I know it's a challenge for all of us right now. So really, I think that what I'd encourage you to do, you've got the experts on the call here. Look in the team, I've got many years experience in the EDA marketplace, specifically there in South Africa. So they're really familiar. They understand the challenges around PCB design, the whole challenges around managing the supply chain and workflow. So I'd ask you really to challenge the team here on the call. They're going to show you some quite amazing things right now. I always love the opportunity to get to meet customers. Normally I'm used to doing it face to face, but I've not been doing that for a few months. So this is my new normal, to be honest, which I think is for all of us right now, sort of working as the virtual environment. But these are three things that I'd maybe just ask you to take away from, and then I'm going to hand back to Lucas. Really just ask yourself, since, the whole pandemic kicked off, you've had to relook at the way you're working, the way you interact with your colleagues, the way you interact with maybe your customers, or you interact with your different members of your supply chain and engineers. Look at what's changed and really think of it from that perspective, because I think that's where working with the EDA team, I think some of the solutions that we're going to talk to you about today can help you. And I think what we're seeing in the business right now is we're accelerating that migration right now to a more online environment for us to collaborate. Okay, I think it's already speeding up a process that's already placed there. So first thing I'd ask you to just challenge the team, ask them what you really need to understand. I know there's lots of design solutions out there for PCB, and I'm sure that many of them make many claims. Challenge the team here around what, maybe the issues you're using on another tool or something you're looking for Altium to solve. And three, really encourage you to give feedback to the team here. We sort of don't look for this to be a one-way type session. So really interact, give feedback to the team. I'm not going to be able to be here for the whole session, but I'll certainly be on for part of it, so I'll be listening in to some of the good stuff. Okay, I'll hand it back to you, Luke.
Thank you very much, Pelle. We greatly appreciate the time that you've taken to join us here on our webinar. It's a great honor to have you join us. And as Pelle said, feel free to ask questions. I'm going to have everyone muted just so that we can keep the noise down, but feel free to drop any questions you have in the chat panel, and I will be addressing them at the end of the session in the Q&A, or if it requires a bit more one-on-one, I'll reach out to you personally, and you can arrange for Zoom meetings or Skype or however you would like to contact, and we can have a bit more of a personal one-on-one, discuss what you need and how we can help you. So let's have a look at Altium and how it can be a valuable tool for your organization. We're going to be starting off with having a look at Altium Live, because Altium Live is the core point from where everything comes from. So I've got a bit of a pre-recorded pieces for this webinar, so I'm going to be switching over to that now. But like I said, if anything comes up and you'd like to ask a question, please feel free to drop it into the chat panel, and I'll be more than happy to assist you afterwards. Altium Live is more than just a website that you can get your Altium downloads from. It is a central hub that you can use to manage your company's users and licenses, in addition to giving you access to a large library of managed components, templates, and reference designs. Altium Live also allows you to connect with a forum of thousands of other Altium users on an international platform, allowing for the easy sharing of design tips and experiences with Altium Designer. Also available is a variety of free webinars on many topics, hosted all directly by Altium, and a full documentation library for all Altium products, making getting information on any function easy and quick. As part of the Altium Live community, the Ideas area allows you to submit and vote on new features and functions you'd love to see in Altium. Likewise, you can also submit and vote on any pesky bugs you encounter in Bug Crunch, because Altium values your user feedback. If anything is unclear on Altium Live, please reach out to EDA Technologies. We are always available to help. I'll be dropping our details into the chat for easy access. Altium Designer makes use of a unified design environment, which means that there is a native connection between every part of your PCB project, all the way from schematic through to the final manufacturer data output, without the need to worry about the import or export of your design data and netlist. Changes and updates can easily be pushed between schematic and PCB with a simple ECO process. Let's start by taking a look at the place that all designs begin, the schematic. Altium Designer's schematic editor is both powerful and easy to use, with the ability to quickly create and connect sheets, components, and buses. You can also easily define and keep track of nets before you even get to the PCB. Altium Designer also allows for true multi-channel and hierarchical design, making even the most complex designs easy to follow. And when changes need to be made, you can take advantage of the powerful global editing tool, making everything much simpler. Altium Designer also allows you to set up differential pairs and special net classes directly from the schematic. And then, once this is done, you can apply design rules to them. When you're ready to transfer your design to the PCB, these design rules will be seamlessly transferred as well. An important part of designing a PCB is deciding what components will be used. This often involves sifting through physical and online catalogs to find the perfect part. Altium's part search tool makes this much simpler, as with a few keywords and filters you can quickly find the parts that you need. Results even include symbols and footprints from Altium's managed libraries that can easily be placed directly into your schematic or downloaded for inclusion into your own libraries. You can also update your existing library symbols with manufacturer and supplier data from a custable range of international part suppliers. This includes everything from availability to pricing and data sheets, which you can then access directly from your schematic, making design review a dream. By adding an active BOM document to your project, you can monitor price, stock, and lead time of any part by a variety of suppliers from around the world in real time. Avoid the pitfalls of obsolete and end-of-life components by getting early warning of lifecycle changes while you're still designing your PCBs. To start laying out your PCB, a quick and easy engineering change order, or ECO, can be done to move all your component and net information over to the PCB editor. Altium's PCB editor includes a set of powerful routing tools that make your layouts a dream, with the ability to route single nets, differential pairs, or even multiple nets at the same time. As well as easy-to-use length tuning tools for single nets and differential pairs. Also included is Ultim's powerful active route tool that combines their intelligent net analyzer, user-driven pathing, and a powerful auto-routing system to make the routing of multiple and complex nets that much simpler. An important part of all PCB designs is defining the board stack-up. Altium's Layer Stack Manager makes it straightforward and pain-free. With a customizable materials library, you can manage all the important data for dielectrics, copper, and surface finishes. The Layer Stack Manager also allows you to set up blind and buried vias with a few simple clicks. Impedance calculations powered by an industry-proven electromagnetic field solver allow you to quickly evaluate and define impedance profiles for any common PCB transmission line type, while taking into account edge factor and surface roughness for accurate results. And when done, you can gain valuable insight by viewing your stack up in both 2D and 3D. Creating and updating a library of components to use is a critical cornerstone of all PCB design. These libraries can come in a variety of forms, and these are schematic and PCB libraries, integrated libraries which combine these into an easy-to-use file, database libraries, and managed libraries with version control that make use of Altium's Concord Pro library management system. In today's webinar, I'll be covering how to create a component with an associated footprint and compiling it into an integrated library. To begin, we go to File, New, then scroll down to Library and select Integrated Library. If you look over in the Projects panel, you will see that we now have a new integrated library project. This will act as a container for both our schematic symbol and PCB footprint. To add a schematic symbol to our library, we will need a schematic library container. We can do this by right-clicking on the project, selecting Add New to Project, and choosing Schematic Library. We can repeat this process to add a PCB library for our component's footprint by going there and choosing PCB Library. At this point, we're ready to start creating our component. So I'm going to save our entire project by clicking on File, Save All, and giving it an intelligent name. I'm going to be calling all our files EDA Library. For this example, I'll be creating a 22 microfarad 0805 capacitor. I'd like to start with the schematic, so I'll head over to my schematic library. Let's start by setting the default designator of our capacitor to C with a question mark, as this is our company standard for capacitors. We can do this by clicking on Properties and changing the designator to C question mark. This question mark will later be changed into a number when we place the component into our schematic. Next, we set our part comment. Typically, this will either be the part's value or part number. For this example, I'm going to be using the value, so I set it to 22 UF for 22 microfarad. Next, we give our capacitor a design item ID. This will be the name of the component in our library. I'm going to use a fairly simple naming convention and call it cap underscore 22 microfarad underscore 0805. If you look further down on the Properties panel, you'll notice that there are no parameters yet set for this component. We'll be getting to that in a moment. But first, I'd like to draw the graphical elements of our component. The first elements to add are the connection pins. We can do this by selecting Place and then going down to Pin. We can now place the pin in the design space, but first I'm going to press Tab and change a few settings. First, I'm going to set the designator to 1 and hide the name. Then I'm going to set the pin length to 200 mm. I will then place 2 pins into the design, rotating the pins as needed. Notice how the designator for pin 2 automatically steps as I place the pins. To complete the graphics of the symbol, I'm going to select Place, Line, and then place 2 vertical lines. I don't quite like the style of these lines, so I'm going to select both and then go into the Properties panel. Here, I'm going to change the line thickness to medium and change the color to blue. Our symbol is now graphically complete, but it lacks any part information. We can easily add this by opening the manufacturer part search panel and entering 22 microfarad as our keyword. Our results are including a lot of different package types, so let's use the filters on the side to limit our results to just 0805 packages. Do this by clicking on Show More and selecting 0805. Our results are now only showing the components we need. The line items marked with orange have potential supplier issues, like this Samsung capacitor. If I expand the supplier information by clicking on SPNs, I can see that one of the suppliers is completely out of stock. Thankfully, DigiKey, our preferred supplier, has got stock. To add supplier and part data to our component, right-click on your chosen supplier and then choose Add Supplier Link and Parameters to and your part name. We can now close the part search and inspect the Properties panel. As you can see, it is now being populated with data from our supplier. Our schematic symbol is now complete. We can now switch to the PCB library to build up our footprint. You can do this manually by placing pads and lines to build up the footprint, but for this example, I'll be using the IPC compliant footprint wizard. To do this, we click on Tools, then IPC compliant footprint wizard. Here, you'll be presented with a list of component types. For this example, we're going to select chip components. Now, we can enter the required data for our component. This can usually be found on the component's data sheet. When you're done, in the lower left, you can choose to generate a step model in the preview, which will update live as you continue to enter component information. When done, click Finish, and your footprint will be generated. You can then add any additional elements, such as silk or different paste data. For our demo, I'm happy with the footprint as is, and our footprint is now complete, and can now be linked to our symbol we created earlier. To do this, we save, then head back to the schematic library. At the bottom of the window, we click on Add Footprint, and here we set the library scope to library name. Then we click on Browse. This will open the library browser. Here we can select our footprint and click on OK. You will now see that the footprint detail is in the model selector. Clicking on OK again will add this model to the symbol. If we switch the footprint detail to 2D and select a pin, we will see that the corresponding pad highlights in the footprint preview. Our symbol is now complete and we can finalize our integrated library. First, we save everything via the File, Save All command. Then, we click on Project and Compile Integrated Library. This will create an integrated library file with our component inside, including all of the supplier links and parameters we just set up. If we look in our Components panel, we can see our new integrated library is now available and that our component is ready to be placed into PCB projects. Draftsman in Altium Designer allows for accurate fabrication and assembly drawings for your PCB design. Easily place and customize assembly and fabrication views directly into your workspace in both 2D and 3D. Accurately measure your board with linear, radial, and angular dimensioning tools. Place various annotations and callouts directly into your drawings for components or other important information. All views are scalable and intelligent, allowing you to collect and show detailed data on your board regions, and specific components. And because the Draftsman is part of the Altium Unified Design environment, you can include things like a bill of materials, layer stack legend, or any other user-defined graphics. The final stages of a PCB project is always documentation, assembly, and fabrication data generation. Altium makes this step very easy with the ability to add an output job file to your projects. Here you can easily set up outputs for all the data you need. Some examples are Gerber and NC draw files, assembly drawings, and pick and place data, the bill of materials, which can also be configured from your active BOM document to ensure that the latest, most accurate data is used, schematic prints and PCB prints, the Draftsman document, and much more. With a few clicks, this data can be saved and used to bring your PCB design from concept to complete. The Altium Designer 3D engine has been allowing engineers to visualize their designs for over a decade. Because this is true native 3D and not simply a viewer, you can work with your design in 3D and make sure everything fits the way it is meant to. By adding 3D models to your component footprints, either by downloading models or by generating them with Altium's Footprint Wizard, you can get an accurate idea of what your finished PCB will look like. This is more than just cosmetic though. By importing a model of your enclosure, you can easily see if there will be any collisions with components, and then, if necessary, move the components into a better position so that there's no longer any problems. Altium is also closing the gap between the electronic and mechanical design worlds with the MCAT Code Designer tool, powered by Altium 365, which allows for the easy passing of design data between engineers. At this time, the Altium MCAT Code Designer tool is available for collaboration with Dassault Systèmes SolidWorks, Autodesk Inventor, and PTC Creo. In today's design environment, PCBs rarely exist in isolation and often need to interface with other boards. Altium Designer's multi-board design tools allow you to bring several PCB design projects together in an easy and intelligent way, enabling you to define board-to-board, cable, and wire-based connection of nets across the entire assembly. Adding a multi-board assembly document will allow you to visualize and position the various parts together to ensure that no components ever get in the way of a perfect fit. And with full support for 3D model imports, you can ensure that everything will fit together correctly the first time. Get full insight into the component requirements for the entire assembly by adding an active BOM document, which can then be filtered to show on which modules in the assembly each component goes. While Altium supplies the tools, EDA Technologies can help to ensure that the right boards are made every single time. If ever you need assistance with your PCB material selection and manufacture, please feel free to reach out to Winston. He has been involved in PCB manufacture for the last 20 years and will be happy to assist you. All right, everyone. So that's covered the pre-recorded section of our webinar. I hope you've enjoyed what I've put together so far for you guys. The next step that we're going to be doing is we're going to be discussing rigid flex design, because this is a big tool in Altium and it's recently caused trouble for one or two of our customers. So I'm going to be covering how rigid flex works in Altium and how to set it up. And this is going to be a live demo that I'm going to be doing for you guys. So I'm going to switch over to my Altium Designer. And as you can see here, I've prepared a version of the Altium Example Flex Rigid Board called Bluetooth Sentinel, which is included in your Altium Designer installs. I've prepared it to get it ready just to show you how everything works. So if I open the Layer Stack Manager by clicking on Tool, Design, and then Layer Stack Manager, you will see that I've got this board set up at the moment as a standard 4-layer rigid PCB. So the first thing I'm going to need to do is turn off stack symmetry option in the properties panel over here, because this is not we're going to be using layers closer to the bottom end of our board. It's not going to be symmetrical in this case. Next, then we're going to want to enable flex rigid mode by clicking on the features tab in the upper right hand corner and selecting rigid flex. Note that there's a new substack section in the properties panel, and there's the new substack controls in the upper right or upper left hand corner of the stack manager. Before we add our flex substack, I'd like to change the dielectric layer that's going to be used for our flex section of our board. In this case, it's dielectric 3. I've already got it marked with a different color here. As you can see, it's currently set to FR4, which, while it's a great material, it's not exactly the most flexible thing. So you can, if you want, manually rename the material to whatever you're going to be using and change the thickness yourself as well. But for our example, I'm going to be using a material that I've added to our materials library. To do this, I can click on these little 3 dots in the material selection, and this will open our materials library in just a second here. There it is. Okay, and then I scroll down and I will select our polyamide material that I have added to the materials library. So here you can see it's now been added into our stack up. We're now ready to add the flex substack to our board. To do this, I click the little plus icon here in the substack manager. And if I open the substack selector, you'll see there's our original rigid section and our new stack. So we can now give the new substack a name in the properties panel. I'm going to call it flex. So here I'll set it to flex. And then I'm going to select is flex. I'm going to check that on because this tells Altium Designer that this is supposed to be a flexible substack. Okay, the next thing that we're going to need to do is to select exactly which layers we want as part of our flex substack, because obviously we can't have everything. So to do that, I'm going to be deselecting the layers that I don't need. In this case, it's those copper layers and the 2 other dielectrics. We're going to be leaving layer 1 and the bottom layer, and we're going to take off the solder mask because I'm going to click on edit and I'm going to add a overlay, which is a special overlay for protecting the material on the flex section. I'm going to switch back to our rigid board, and you can see that it's disabled for there. And then if I click on Tools, Layer Stack Visualizer, and then click on Show Full Stack, we can see our full rigid flex stack up in both 2D and 3D view. And I can even just separate it a bit and show you the relative layer heights to each other. So now that our stack up is complete, we can start setting up our PCB. So the first thing I'll need to do is a file and save stack up to PCB. This is just to ensure that our PCB file has been updated with the stack up. And I can head back this side. Now that we're back at our PCB, in order to set up the various regions that's going to make up our flex rigid, I can press 1 on my keyboard and that enters board planning view. You can see here that the board is turned green and it's marked that it's part of the rigid stack. In order to split the board into different regions, I'm going to need to use some board region split lines. I can do this by clicking on Design and then Define Split Line. Now, how this works is I select a point and then I'm going to select a second point, like so. So I want to go from here and I take it across to here. And let's just move that into the correct position there. And now you can see I have 2 separate regions on my PCB. So to complete this section, because I've got 3 sections to my PCB, I'm going to add another defined split line. And I'm going to add it on the bottom side here. So click there, move across, and drag it down into position. So now, as you can see, we have 3 sections to our PCB, but they're all still marked as rigid. So where's the flex coming in? Well, let me show you. It's because the central band is going to be our flex section. You can see I've already got my dimensions and everything marked out so I can place things easy. I'm going to double click on it. And this allows me to give it a new name and to select what layer stack it's going to be using. So in this case, I'm going to call this the flex area. And I'm going to use the flex substack and click OK. And as you can see now, it has been updated. So this is rigid, rigid, and flex. And you can see there it will use the correct substrate. And second thing is, because the bottom half of our PCB here is going to be the part that I want to act as the base of our flex rigid design, I'm going to 3D lock it. This will become a bit clearer a little bit later once I've explained how everything is working here. So I'm sure now you've noticed that there's this yellow line with a yellow area around it in the flex area. This is a bending line. This defines how the flex is going to bend in Altium Designer. So because of the setup for this, I already know how everything's going to fit together for what I need. So I'm going to quickly just move this across to here. All right, and just a second here. I just need to pull up one of my settings that I've got. Just a second. Okay, so I'm going to define a few more of these bending lines, but to give an idea quick on how to fully define this one as it is, just a second here. My computer's not behaving with me at the moment. I apologize. All right, so what I can do now, sorry, now it's behaving a bit, is I can click on PCB, and then I set my PCB panels scope to layer stack regions. If you're in your PCB document and you don't have the PCB panel, you can access it by clicking on panels, and it will be located here, this PCB panel. All right, then I select our flex substack, or flex region, and here you can see our bending line has been defined. If I double click on it, it allows me to choose the bending angle, the radius, and the fold index. The fold index is the order of folds that's going to happen with the PCB once it's ready. So in this case, this section is going to go to minus 145 degrees, minus 145. And I would like to have it as a radius of about 13.435 millimeters. And my fold index for this is going to be 2 because I want it to be the third fold that's going to happen. It starts at 0. So the sequence always starts at 0 and moves up from there. So because this is not going to be the only bend on my board, I'm quickly going to say here, design, define bending line. I'm going to define a second bending line over here. This one, as you can see, has now appeared in the bending lines, and I'm going to set it to minus 145, and I'm also going to set it to 13.435 millimeters with a fold index of 2, because this means that when it comes to this point's fold index, it will fold both of them at the same time. I'm going to set up quickly a few other bending lines. In this case, it's going to be here to here and here to here. Those are going to be, those need to go to minus 90. And that's correct. And that's going to be, the first fold. And then this one I set to 3. And set that to minus 90 as well. Oh, goodness. The minus 90. And then just 2 more to add for this particular project. It goes from there. Oh. Comes from here to there. And from there, straight down again. All right, and those 2 I'm going to set to minus 25 degrees because it's going to be working with the other fold line. And I'm going to set this to fold index 1. And this one I set to minus 25 degrees as well, and also fold index 1. And there we go. I've now set up all the fold and bend lines for my PCB. As you can see, it's all ready and set up. You can now go back into regular placement mode by pressing 2 on your keyboard, and you are ready to start doing the placement and routing of your components. To save time, I've already got a version of this that I've set up beforehand, which I can just quickly open from my recent documents. And it's got a fully placed and routed layout. This is one of Altium's projects, as you can see. So now we've set up a whole bunch of fold lines and such. To what end? So if I switch into the PCB panel and go back to the layer stack region selections, you'll see that there's a fold state slider at the bottom here. So if I switch into 3D view in Altium, and I slide the fold state slider, you can see in real time how the PCB folds together using our defined fold lines. And then I can open it up again. And what's useful with this is if there's any components that would, say, for instance, collide with each other, they will get then marked as a collision. For example, let me switch this ICU1 to the other side of the board quick. I'm just going to select it there, change its properties here. I'm going to set it to bottom layer. And if I switch back to 3D, you can see that it is now flipped to the other side of the board. So if I now fold my PCB together, it's okay. This is a fairly narrow component, so it's not actually colliding. Let me just select a different component then to move. Sorry about that, guys. Oh. Okay, I'm going to select this one. Let's move this to the other side as well. Bottom layer. That should now collide and cause a error. Okay, goodness, it's not working now. Sorry, guys. It was working earlier when I tried it. It's glitching out now. But yeah, so we've now set up our flex rigid board, and you can see how it folds all together. And it should be highlighting those components in green, like you saw in the 3D placement video that I had, where it just marks that there's a collision. I think I've got my design rules a little bit off at the moment, so it's not working properly as it should be. But now, say for instance, you need to give this over to your mechanical guys. Exporting the flat model, they can fold it themselves most likely, but it's easier if you fold it yourself here. And then you click on File, and you can go to Export, and you can say Step 3D. And then, so I want to export this board, and here you can set the export folded board. So you can actually export a 3D body in its fully folded state or partially folded, however you would like to do it. So we're going to export it at a 100% fold, and it's as simple as that. All right, and that covers the setup of the Flex Rigid design in Altium Designer. So let's say I want to, okay, I'm just going to be closing this one that I've already done. Now let's say I've set up the board like I have over here, but I'm more of a guy that does the MCAT stuff, and I need Nishan, for instance, to do the placement and routing because that's his specialty. But previously in Altium, I'd have to right click here and say project packager, put it into a zip folder, put it up on our server, send it to him, make sure that he's got the correct revision. Altium has now made this much easier using Altium 365, as Pele mentioned earlier in the webinar. So what I can do is I'm going to just save everything here as part of my design, just to make sure that everything is saved. And here you can see that I've connected to our Altium 365 workspace already, as you can see. And something simple I can do is I can just right-click on the component and make the project available online. And then I give it a name, so it's going to be Bluetooth Sentinel. I give it a full description. It's the Altium sample project. And I can then click on OK. And now what's happening is, yes, we will do that because it's just making use of these reused documents there. And as you can see, there's a little cloud icon next to the Bluetooth Sentinel icon there, which means that it's now being made available online. If I switch over to my Chrome browser, and I'm now in Altium 365, if I refresh my page here, the project should be available now. And there it is. All right. Okay, it looks like it's still busy loading all my parts. But that's as easy as it is to get it into Altium 365. So there you go. If I open my design, you can see there's all my documentation. You can see here, and there's the PCB. And it's still busy syncing across. And there you can see as all the components off to the side, and there's the PCB. Now let's say I want to add Nishan to the team. I can do this easily by just clicking on Share. And then what I'm going to do here is I'm going to say whoever I'm sharing with can edit, and I'm going to enter Nishan's email. All right, and add him here. He's already part of our group, so there he is. All right, and then I can just click on share. Okay, it's not allowing me to add more than one editor. I think it's glitching out there for a second, but I can click on share and it will easily share the project to Nishan. He'll get an email. He can then access it directly. And within Altium Designer, if I switch back here, if I say file and then say open project, all right, you'll see here that it's giving me an option to open recent projects, local projects, or projects from our 365 cloud. So let's say I want to open one of the projects that's, let's open the KMPDB. This is one of the default projects that comes preloaded as an example in Altium 365. I click on that, and it pulls all the information from the Git repository that Altium 365 uses. It's just taking a little while. Just give it a sec. And there you go. There you can see there's the PCB at the bottom there. And you can see there's the little green tick marks indicating that it's coming from an online server. And I can open the schematics. I can open PCB documents. So let's give it a second here to open. And I can now work on the document as I normally would, like any engineer would in Altium Designer. So say for instance, I make some changes, I add some silk or such. I can then save everything, and then I click on right click it and say save to server, and it will do a revision update. So let's do a quick silk edition here. So I'm going to say view configuration, and I'm going to turn, okay, so my overlay is on. Let me just open it here. All right, let me just move across to overlay. Okay, that's just, sorry, there's quite a bit of layers in this one, the top overlay. And let's say I want to move the Altium logo that I've got here on the top overlay. So I'm going to select, and then I'm going to say inside area, and put in a single layer view, and just, come on, select it now. I'm not sure why it's not selecting now. Oh, wait, I've got my filters on. There we go. I can select it. And I say move selection. And let's move it to the bottom of the PCB, because that's where I'd prefer to have the logo for this case. Now you can see here, if I save the document, You'll notice that the little green tick has now moved to a red circle, indicating that this document is modified and it's not the same as what's on the server. So in this case, I can right click and I say save to server. And it then brings up the commit to version control, where it's showing what was modified, and I can add a comment. So here I can say moved logo on silk, and then I can commit and push. If I head back over to the Altium 365, and I just head back to, let's go back to here, and I click on to the KMPCB or KMPDB document. This should now have updated to show the new silk. Just give it a second to load everything. Okay, it's taking a bit of time. So I'll come back to this in just a second. I'll continue on with some of the other points in my webinar, and we'll get back to this in just a second then. All right, so one of the things that a lot of people are going to wonder now, especially if they're going to be moving on to Altium Designer, is what happens if you're using another package? Luckily, there's no need to worry about what moving to Altium Designer is going to do. You won't need to remake any of your projects that you've already got and such, because Altium Designer includes an incredibly powerful import wizard. Our previous webinar that we did a few weeks ago, we covered the import of a project from Autodesk Eagle into Altium Designer and then editing it from there. To further expand on what can be imported into Altium Designer, you can import projects from the following packages: Proton 99 SE, Cadence Allegro and Cadence OrCAD, Zuken CADStar and CR5000, Mental Graphics Expedition and PADS, PCAD, KiCad, which is a relatively new addition to the Altium Importer Wizard, because we had a lot of people asking for the KiCad import, because a lot of people are using KiCad and now we can't import into Altium. So a lot of people were giving feedback in the ideas section, and Altium went and made a KiCad importer because there was a lot of people asking for it. So yeah, Altium does value your feedback. And then of course, like I mentioned, Autodesk Eagle. One of our recent customers was prior to joining with Altium Designer. He was an Eagle customer, and he was able to, within a month, pull all of his old designs into Altium Designer with no issues whatsoever. So that just goes to show how powerful Altium Designer's importer is, that he didn't have any problems and such. All right. Then if you're unsure if your current platform is supported for import, or if you'd like to know more about the process of doing an Altium Designer import, feel free to reach out to me and I'll be more than happy to assist you guys. All right, and that brings us to the main end of our webinar. I'm going to switch back to the 365 because I saw that finished there. And if I go to the PCB, you'll see that the logo has been moved to the bottom here. And say, for instance, like here, if you're viewing in the viewer, let's say I want to add a comment quick. So I'm going to say box comment and select the logo. I'm going to say move back to top because the logo is better there. So I say post. And then if I switch back into Altium 365, you can see there's the note or if I switch back into Altium Designer, there's the note that I just placed in the web interface for Altium 365, which means that you don't even need Altium installed in order to do design review with a customer. They can view it all entirely in the web interface, make their comments, make notes, and you can update things in almost real time. So I see that there has been a few questions in the group chat. So I'm going to get on to addressing those in just a second. I'm going to see here. So I see Arno's asking, with the departure of Ben Jordan, will Ultim be getting a new brand ambassador? Arno, let me follow up with Avantika and Pele, and I'll get back to you with regards to the brand ambassador and the useful tips that Ben used to share with the community. I'll get back to you on that. I'll get back to you as soon as I can. And I see here, Ari is asking how to add a material to the StackUp library. All right, let me quickly show you. It's a relatively simple process. So I switch back to my Bluetooth Sentinel project. I'll be using that as the example. So to do that, I first say design, and then I open my layer stack manager. There we go. And then I can click on tools and go to material library. And this will open my full materials library. Here you can see it's got surface finishes, PCB materials, dielectric materials, surface layers, even special for printed electronics. Altium has support for printed electronics. It's where you can 3D print with conductive materials. Altium does have support for the printed electronics. I haven't covered it in the webinar because I'm not too familiar with it myself, but if you guys want, I can do a topic on, I can cover this in a future webinar, is the printed electronics. So to add a material, say for instance, I want to add another, let's say dielectric material. So I select dielectrics, I'll select core, and then I can click on new. And then here you can enter in the manufacturer's name, the material's name itself, which will show up here. You can enter in how thick it is, constructions, what resin percentage it has, what frequency it supports, the dielectric constant, the glass transition temperature. You can add all of that into the Altium materials library, and then that can be added to output documentation as well. Okay, and then I see Quibi here is asking how critical are the positions that I just placed. Quibi, if I'm not mistaken, that you're asking about the bending lines, yes? All right, yes, okay, so the bending lines and the folded things. They're not super critical. I can move this around a little bit, but obviously this angle here, for instance, does matter. So if I change it here, and then I go back into 3D view, when I adjust the, let's just quickly switch back to layer stack regions. When I adjust the fold state, you'll notice that here that that particular arm is going to fold a little bit differently. As you can see there, it's now folding a little bit differently. So it's not super critical because, again, it's not going to impact the final output. This is more for just a MCAT and visual output. So it's just so that you can get a more accurate view there. So there's that. Then I see Ari is asking if I can cover flex rigid panelizing. So panelizing in Altium Designer is actually relatively easy. So if I do this and I shrink that down, so the easiest way to panelize in Altium Designer is to just add another PCB document to your design. Okay, and then I'm just going to quickly save here and then just add that other assembled document quickly, just so that I can work with an assembled board. Okay, I drag that in to just join it to the project. All right, and then I go over to this new PCB. Let's save there. Okay, and I save the new PCB. Now, the easy way to do the panelization in Altium Designer is you can say place, and then you can say embedded board array and /panelize. And then you get this little green flag that says no source. So I'm just going to place it down for now. And I open it in the properties panel. I'm double clicking it here, or you can just single click it and open here the properties panel. So I'm going to edit here, and then it's asking what the source document is. So what I'm going to do is I click on the 3 dots, and I'm going to select the Bluetooth Sentinel routed and click on open. And now you can see there's my Bluetooth Sentinel. Okay, now let's say I want to include 2 PCBs. I want to include it on a 2x2 panel. I can click OK, and there it starts panelizing. Obviously, you need to adjust your row spacing quite a bit. So let's set that to 1000 mil. Let's say that's going to be our panel. We can then, on mechanical 1, I'm just going to say place a line, and I draw a nice rectangle around that for our panel. Let's just get that to snap there. Oh, that didn't quite complete. All right. And then I select a piece, press tab to select everything. And then I say design, board shape, define from selected objects. And there we go. Oh, let's just move that to be a bit more centralized. And design, board shape, define from selected objects. And there we go. There's essentially a board panel. You can then obviously add all your cutouts and routing and such to that to give a bit more accurately. So doing this is the quick way to panelize within Altium. But if you're asking about building stack-ups and such for actual manufacture, it would be best to reach out to Winston. He's been Winston or Nisham, both of them. They've been involved in PCB manufacture for quite a number of years, and they know stack-ups, they know the technology. They'll be more than happy to assist you with your stack-ups and costing and best practices to use when doing flex rigid panelizing. Is there any other questions that anyone would like to ask, or? All right, then I'm not seeing any more questions coming through, so I'm going to bring this webinar to an end. If you do think of anything that you'd like to ask, feel free to reach out to me. I'm going to I dropped my contact details in the chat panel a little earlier. Feel free to send me an email, get me on Skype, give me a call on WhatsApp. I'm always available to assist you. If you need any assistance with Altium Designer, you run into any technical problems, again, reach out to me. I'll be more than happy to assist you. I'm always available for technical support, and I'll get back. I'll be more than happy to help you. All right then, enjoy the rest of your day, everyone, and stay safe.